Welcome to another video of the power quality. In this video, we are going to have a discussion on the analysis of a quasi-square wave, which is having a pulse width of 120 degree, like 2/3 of the pulse in the upper half and 2/3 in the lower half. And the red line that is been shown is the fundamental component of the current. So the current is from 30 degree to 150 degree, it is ID, and from 210 to 330 degrees, it is minus of ID. And we have to find out what is the crest factor. So the crest factor is nothing but it is equals to I value, ID peak value, the peak value that is have divided by the RMS value. IRMS, we also called, we can write it is IS. If we noted this as IS, and if we note this one as the fundamental component as IS1. So this is what the crest factor will be, and the distortion factor DF will be IS1 divided by IS. IS1 is the RMS value of the fundamental component of the current, this dotted line, and IS is the RMS value of this quasi-square wave. And the last one is the THD, total harmonic distortion. Total harmonic distortion is IS square minus, this is the total RMS value, minus the IS1 square fundamental component divided by the IS1 square. That means if I can find the value of IS and IS1, my purpose is solved. So let us go to the another screen. Let us find what is the value of IS here. IS is the RMS value, so we know that to calculate the RMS value, like IS square, or if I write IRMS square is equals to 1 by 2 pi integration of 0 to 2 pi I square theta d theta. That's a formula. So what here we can write this as IS square 1 by 2 pi. Instead of that we can write 2 by 2 pi. So 2 times because of symmetry, and we can take it from 0 to pi. So between 0 to pi, it is not 0 to pi, rather it is from 30 degree to 150 degree. What is 30 degree is pi by 6, and 150 degree is 5 pi by 6. And the value of I, we can write down here, I of theta is equals to ID from pi by 6, or let us write from 30 degree to theta less than equal to 150 degrees, and is equal to minus of ID from 210 degrees to theta to 330 degrees. So this is the current equation. So it is a square of it, so I square d theta. That's very simple. So we can write this as I square by pi, and theta limit from pi by 6 to 5 pi by 6, that is 4 pi by 6, that is 2 by 3 pi. So that is I square by pi into 2 by 3 pi. This pi get cancel out. So ultimately we can write down this IS square is equal to 2 by 3 ID. This is ID. Okay. ID square. And that implies IS is equals to root over of 2 by 3 ID. So we get the value of RMS value like this. And that's come out to be that value of IS is equals to 0.8165 ID. So that's the value of IS. We get it, right? Next, we need to find out what is the value of IS1. So let us go for another screen. Yeah. So here we need to find IS1. That's the objective. What is the value of IS1? So it is actually the IS IS1 is this waveform, and we can write down that IS is nothing but this IS is this square waveform, right? IS is nothing but it's if we do the Fourier series analysis of it, it is nothing but IDC plus summation of an cos n theta plus bn sin n theta where n from 1 to infinity. So since it is symmetry, we don't have the DC component, we don't have the cosine component, we'll have only the Bn component. So we can write down that B1 sine theta, and we will be getting only the R harmonics over here. So B3 sine 3 theta and so on. And from here we are interested to know what is the B1. So B1 is a peak value that reflects over here. This is the value of B1, the peak value. And the RMS value, so RMS value IS1 will be equals to B1 by root 2. So what's the value of B1? So B1 is nothing but the fundamental, or let us say find out Bn first. So Bn is 1 by pi integration of 0 to 2 pi I theta is theta and sine of n theta d theta. That's the value of Bn. So let us apply. Instead of 1 by pi, let us say 2 by pi and integrate from 30 to 150 degrees. So 30 is pi by 6 to 5 pi by 6. Is is nothing but id and sine of n theta d theta. That's the integration. So 2 id by pi, we take it common. Integration of sine of n theta is cos of n theta divided by n, that's a negative. So we will interchange the limit. So 5 pi by 6 will be here and pi by 6 will be here. So this will leads to 2 id by n pi and cos of n pi by 6 minus cos of n 5 pi by 6. That's the value. So we can again rewrite that 2 id by n pi cos a minus b, cos a minus cos b will be equals to 2 sine a plus b by 2. That's nothing but n pi by 2. Because n pi by 6 plus n 5 pi by 6, that is n pi divided by 2. Another will be sine of b minus a by 2. So 4 pi, 5 pi minus pi, that is 4 pi by 6, which is nothing but 2 pi by 3 divided by 2, it will be n pi by 3. So here this is what the answer is, Bn value is. So from this we can write that B1 is equals to 2 into 2, this is 4 now here, 4 id by pi, and when we put n is equal to 1, the sine n pi by 2, this will be 1, and sine pi by 3 is root 3 by 2. And when we calculate this, this comes out to be 1.102657, like that. So that's the value of B1, and we are interested for B1 by root 2. So dividing this by root 2 will give us the value as 0.7797 id. So we can write, in short, this is 0.78 id. So like that also we can write. So here we get the value of IS1, and in the previous we have got the value of IS. So when we use these two to substitute the values over here, so let me write the value of IS and IS1 over here. So these values are there, IS and IS1. So here we can find the value of crest factor is ID and IS is 0.8165 ID. So we get the value. This is 1.2247, and when we get the value of IS1, that is 0.7797 ID divided by 0.8165 ID, that gives us nearly 0.955. That's the value of the distortion factor, and THD will be, let us see, I'll put the value of IS here. IDs will cancel each other. And this comes out to be 0.31084. So that's the value. So we can write TSD is 31.084%. We can also write TSD as this, and that distortion factor 0.955 and the crest factor 1.2247. Thank you very much.